Now it's time to control Lightware devices. Here at Lightware, we are proud to give you the opportunity to access most of the Lightware device's internal properties and functions. For control purposes, we developed our own programming language that is called the LW3 Protocol. The LW3 Protocol is a case-sensitive text-based language that was developed for the easy understanding of the communication between a Lightware device and any application or terminal. To begin with, I'm going to show you how to cheat this system. I know many of you arrived without the need to understand the entirety of the LW3 protocol. I'm going to show you a trick on how to access the LW3 commands without the entire understanding of our programming language. When you open up Lightware Device Controller, you may already notice that on the bottom right corner you can find an Advanced View button. When you press that button, a terminal console is going to pop up. When you open the Advanced View tab, on the left side you can see a terminal there. If you make any modification in the LEU software, this console is going to show you the entire LW3 communication between the device and the LDC. So for example, if you are making a cross-point change, you will be able to track the LW3 command of the cross-point change in that terminal window. You can simply copy and paste from this terminal window. The only thing left is to add a carriage return and a line feed character at the end of every line of commands that you send to the Lightware device. This is going to be completely compatible with our Lightware devices. You can use any external controlling platform to send these commands. Now, for those of you who are still with us, let me explain the theory behind the LW3 protocol. The LW3 protocol uses a node structure that is quite similar to the folder system in any computer. All the methods and properties are organized in a logical structure that is called the LW node tree. The Lightware commands consist of four main parts. The endpoints of this node tree can be methods, properties, or nodes themselves. The first element is the control command, followed by the node path, and at the end of each command is either a node, a property with a value, or a method with a parameter. On this slide, you can see the full syntax of every possible Lightware command. Please do take a moment to pause this video and read through this table carefully. To get information about a node, a property, or a method, you can use the get or the getAll commands. In case of writable properties, you can use the set command to set the value of that property. You can call methods with the call command. You can subscribe to certain nodes with the open command. This means that the Lightware device is going to notify you whenever there is a change within a specific set of properties. Of course, you can unsubscribe using the close command. Last but not least, every node, property, and method has a so-called manual that is a human-readable text which explains the exact parameters or values of the given property, method, or node. Every line of command ends with a carriage return and a line feed symbol that I'm going to explain in a minute. But for now, let's see examples. These examples were taken from a torus unit, so if you have one in front of yourselves, you are free to try them. First, you can query any kind of health status related parameter, for example the CPU temperature. You can do it with the get command followed by the node path and finally the CPU.temperature parameter. Of course, at the end we need the carriage return and the line feed symbols. Quite similarly, you can query the presence of an input signal, for example on input 1. This is also done by the get command, the given node path, and the signal present parameter at the end. You can, for example, disable HDCP on any given input. You can do it by setting the allowed HDCP version parameter to an off value. If you want to mute the analog audio output of a torus, you should set the mute parameter of the output 4 to true. Switching the cross point can be done with a method call. In this case, it is going to be the switch method with the given parameters. If you need to reset a Lightware device remotely, of course you can do so with the LW3 protocol. You should simply call the restart function of the device. If you want to check the control commands of your specific Lightware device, you should download the manual. It contains the specific control commands for every situation. Upon receiving a command, the Lightware device is going to answer with a standardized response. The first two characters of this response is going to be the so-called header or prefix, which contains useful information about the nature of the response. Please take a moment to read through this table as well. Understanding the prefix of the responses is going to make Lightware programming much easier. Now let's see what happens when we use the LW3 protocol to send a message. At the end of the day, the Lightware device is going to send that message in a binary channel. So you have to understand really carefully how the Lightware device translates the text to binary values. By default, the message is translated as text, so the Lightware device is going to send the ASCII value of each character. However, for example, in the case of the uppercase A character, this can be understood as a hexadecimal character as well, in which case we have to translate it to the hexadecimal value. This is going to result in a different binary code. Quite similarly, if we take the character 0, it can be understood as a text character, in which case we are going to send the ASCII value of 0. And of course, it can be understood as a hexadecimal number as well, in which case we have to send the hexadecimal value of 0. In the LW3 language, the character that makes the difference between a text and a hexa character is the \x character. The \x tells a Lightware device that the following two symbols must be interpreted as hexadecimal values. So in our case, 0A could be understood as a text, in which case it would be translated to 16 bits of data. \x0a is going to be translated as a hexadecimal value, in which case it is going to be 8 bits of data. Now let's take a moment to understand the carriage return and the line feed symbols. These symbols come from the time of manual typewriters, which actually had a carriage that had to be returned at the end of every line. At the time when the ASCII table was made, manual typewriters were pretty much still a thing, so the ASCII table contains these two characters. In the world of informatics, these are often used to mark the end of every line. These characters are so-called non-printable characters, which means they cannot be seen in a text, but they mark the end of every Lightware 3 command. The Lightware 3 device is not going to respond to any command until it receives a carriage return and a line feed symbol. If you send multiple commands to a Lightware device with only one carriage return and line feed symbol at the end, the Lightware device is going to be unable to decipher the multiple line command, so the carriage return and line feed characters have to mark the end of every single line. In the LW3 protocol, you can use the hexadecimal value of these two symbols, so you can write \0d and \0a, or you can simply write \r and \n. The last special feature of the LW3 protocol is the so-called escaping. There might be use cases in which an entire LW3 command is used as a parameter of another command. For example, in Event Manager, when you set the action part of an event, that is going to be an LW3 command given as a parameter to the action part of the event. Now, in this case, if the LW3 command contains so-called special characters, you have to use an escaping symbol before them. This helps the Lightware device distinguish between an executable command and the parameter. So to sum up, if you are using special characters as parameters, you should escape them, which helps the Lightware device understand that this is still a parameter, not an executable command. If you want to get started with the LW3 protocol, I suggest you go to Lightware's OpenAPI website and download the documentation. This contains all the essential information about the LW protocol and how to get started. You should also have a look around the advanced window. It is going to make you understand the LW3 protocol pretty quickly. You can also find detailed information if you click on the LW3 help button. If you want to practice sending commands to a lightweight device, you can get started using the command window. And with that, I thank you for your attention and see you in the next video.